The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of a Number with the two zeros as the lowest digits. Example, 53,600. In the previous example, 96,100, we got the square root 31 with the first three digits of a number. As we had two zeros in the lower columns of the number, we simply added one zero to the square root, making it as 310. However, the child should not mistake that all numbers having two zeros at the end will give perfect squares. Let us demonstrate with the example 53,600 that this number does not have a perfect square root. We had mentioned that for calculating the square root, we have to group the numbers from the right side. Therefore, the first group is 0, 0. The second group becomes 36 and the third group is 5. For the purpose of calculation, we consider the groups as 5, 36 and 0, 0. Let us set the number 53,600 by leaving three columns in the right extreme of the abacus. That is, the lowest zero is set in the thousands column, 0 in the 10,000s column, and the number 6 to the left of the 0, followed by 3 to the left of 6, and finally 5 to the left of 3. Take the first group, here it is 5, and consider the perfect squares there. 4 is the only perfect square in 5, and therefore take 2 as the first digit of the square root. Set 2 by skipping a column to the left of 5. Now 2 must be multiplied with 2 and the 4 should be subtracted from 5 and we get the remaining value as 13,600. In the next stage, double the number 2 and set that 4 in the extreme left of the abacus. Now consider 4 and 13 of 136. As there are 3 4s in 13, the second digit of the square root becomes 3. Set this number to the right of 4. Now 3 is multiplied with 43, that should be subtracted from 136. 4 multiplied by 3 is 12 and that should be subtracted from 13 and you have the remaining value as 16 in this stage. 3 by 3 is 9, that should be subtracted from 16. So we can't subtract 9 from 6 and therefore subtract 1 in the left column and add 1 with the 6 and therefore the remainder at this stage is 700. Let us take the twice the value of the square root 23 and it becomes 46. That should be set in the extreme left of the abacus. As there is 1 4 in 7, let us take 1 as the third digit of the square root. Therefore, making it as 231. Let us add this 1 to the 46 too. That means it will become 461. Now, 1 should be multiplied with 461. That should be subtracted from 700. That is, 4 should be subtracted from 7. That means subtract 5 in the upper abacus and add 1 in the lower abacus. Now, for subtracting 6 from 0, subtract 1 in the higher column and add 4. To subtract 1 from 0, subtract 1 in the higher column and add 9 in the lower column. Now we are left with 239, which is the remainder, and therefore 53,600 is not a perfect square. This gives an understanding to the child that having 2 zeros at the end of the number does not mean that it will give a perfect square root. In later part of this section, we will also deal with imperfect squares, but at this stage the purpose is to demonstrate that the child should not be mistaken that having 2 zeros at the end of the number might give a perfect square root.